Let's go over the steps for factoring, okay? Because I think some of you are not sure where to start, okay? So, what do we always do first for a factoring problem? What's it say?
Greatest common factor.
Yeah, look for a greatest common factor, right? Always do that first, okay? That makes life easier if there is a greatest common factor, okay? Now, number two is a binomial because it's got two terms. Number three is also a binomial, only two terms, okay? So if it's only got two terms, it's probably one of those two things, all right? You guys know what perfect squares look like, right? Any variable to an even power, you know the numbers 1, 4, 9, 16, 25, 36, 49, and so on, right? You know those are perfect squares. If you're not sure something's a perfect square, just take the square root of that number on your calculator. It'll tell you, right? But it's got to be subtraction to do that. And then there's a certain way to do those, right? You take the square root of both, front and back of both, one's plus, one's minus, right? We've done enough of those that you should have those down by now, okay? But again, we're going to keep practicing, but you have to know these steps. Makes your life, factoring life, much easier, okay? The sum or difference of cubes we did yesterday. That's when you had the binomial and the trinomial answer. Cube root for the binomial, both of them. If it's addition in the beginning, it's addition in the binomial. All right? Then your trinomial is the first term of the binomial squared. All right? Your middle term is multiplying the two numbers in the binomial together. Make sure if it's a sum of cubes, your middle term's minus. If it's a difference of cubes, your middle term's plus. Remember, those were opposite. Your third term was always positive, and it's the second term of the binomial squared. Okay? And it seemed to me like you guys had it down when we practiced those yesterday. Okay, number four is one of those special trinomials, three terms, because it's a trinomial. The first and third are positive perfect squares, and we did the 1, 2, 3 test. Okay? Number one was the square root of the first term. Number two was the square root of the third term. Number three, multiply the answers from 1 and 2 together. If number three's answer was half the middle of your trinomial, that b value, then it was one of those. And then we just put number one in the front, number two in the back, whatever b's sign was, and squared it. Okay? If you didn't recognize it's one of these number fours, you can do it as a regular trinomial and it'll work. You'll just write it twice, like x plus 2 times x plus 2, that's all. All right? Now, we didn't have any when a was 2 or bigger. All right? Maybe we'll run into those on our homework going over it. Okay? And then number 4 is grouping, when you had 4 or more terms. And remember, factor completely. Sometimes after you factor, one of your factors is a difference of squares or a sum or difference of cubes. Okay? Or a special trinomial or something. Okay? So make sure you do that. So you need to know this steps of factoring. I go through that in my head every factoring problem. It helps me figure out what type it is. And usually once you guys know what type it is, you're good at factoring. But I think getting to what type it is some of your problem. These steps should help you. So, take a picture of it, write them all down, look on Canvas, however, but have it close by so it'll help you. Okay? So back to the warm-ups. All right. Is there a GCF for number 7 there? Is there a number or variable that goes into all three? Yeah, just a variable, right? So what can I pull out of there? W to the 8, right? Oops. So 10w to the 10th divided by 1w to the 8th is 10w squared, right? Negative 19w to the 9th divided by 1w to the 8th is negative 19w, right? And then 6w to the 8th divided by w to the 8th is 6. All right, so there is one of those where we have a trinomial and a isn't 1, so it's a little tougher. All right, we take the a and the c value and multiply them. What's 10 times 6? 60. Are there factors of 60 that add up to negative 19? Yeah. 15 and 4, right? Negative 15 times negative 4 is positive 60. But when I add negative 15 and negative 4, I get negative 19, right? So here's what we did when we had this type. We rewrote it as 10w squared minus 15w minus 4w plus 6. We turned it into a grouping problem. We took the two factors of negative 60 or positive 60 that added up to negative 19 and put them in place of the negative 19. And then we just do it as a grouping problem. What's the GCF for the first group? 5w. What's the GCF for the second group? Negative 2. Whenever that third term is negative in our group, pull out the negative sign. All right? What's 10w squared divided by 5w? 2w, right? What's negative 15w divided by 5w? Negative 3, right? What's negative 4w divided by negative 2? 2w, right? What's 6 divided by negative 2? Negative 3. Are the black binomials the same? Yeah. And then that's one factor. What's my other factor? The blue ones, right? The 5w minus 2. So our answer now, finished answer. Don't forget, w to the 8th we pulled out. And we got the 2w minus 3 and the 5w minus 2. Okay, so we didn't go over one like that yesterday when we had a value that wasn't 1. Okay, but we did those, it's been a while. We did a couple days of factoring before we went into our quadratics in chapter 3, I think it was, maybe 2. I forget now. All right, questions on that one? No questions. We're okay? Understand how I got everything? Okay.
Generation, attention to all students attending the University of Agriculture. Please report to door 9 by the guidance office now. Thank you.
So, GCF here for number 13. What is it? 4h to the 6th. Yeah. What's 4h to the 9th divided by 4h to the 6th? H to the 3rd. What's negative 256 h to the 6th divided by 4 h to the 6th? What's 256 divided by 4? Is that 64? All right. So I got two terms. Are they both perfect squares? No, that's a perfect cube, right? Are they both perfect cubes? Yeah. So it's one of those difference of cubes we learned about yesterday. So 4h to the 6th. No x in there. And then I got my binomial, my trinomial. What's the cube root of h cubed? H. What's the cube root of 64? 4. So that's just h minus 4. Just took the cube root of both of those. Okay, my trinomial. Take the first term here. of our binomial, this h, and square. So h times h is h squared. So that's a minus, my middle term is a plus. Just multiply those. H times 4, 4h. Third term is always plus. And take the second term of the binomial and square it. 4 times 4 is 16. So there's our answer for that. Factored completely. Okay? So, answers to homework problems. We started at number 3. 3p cubed is the GCF. Then we get a p minus 8 and a p plus 8. Number 6, r to the 4th is our GCF. And then we get 3r plus 4 and r minus 5. Number 9 is a difference sum of cubes. And we get x plus 4 for the binomial and x squared minus 4x plus 16 for the trinomial. For number 12, we have a difference of cubes. We get c minus 3 for the binomial, c squared plus 3c plus 9 for the trinomial. Number 15, take out the 2t to the 4th, and then we have a sum of cubes. And we get in the binomial 2t plus 5, and the trinomial is 4t squared minus 10t plus 25. Let's stop at 15. Any of those you have a question on? You want me to go over? Okay. 18 we skipped, so 21 is 3a squared plus 8 and a plus 6. That's a grouping problem. 24 is z minus 3, z plus 3, and z minus 5. You should have gotten a z squared minus 9 after you did your grouping, but that z squared minus 9, remember, is a difference of squares. That's why it broke down to z plus 3 and z minus 3. So if you had the z squared minus 9 part, you just didn't finish. You didn't factor completely. 27. 7k squared plus 3 and 7k squared minus 3. Looks like it was a difference of squares. Number 30 is y squared minus 7 and y squared plus 4. And then the last one, 33, 3r squared is the GCF. And then you get r cubed plus 5 and r cubed minus 4. So any from 21 to 33. Jordan? Sure. All right, there it is. Okay, so is there a GCF for those three? No. So it's got 3 terms. So number 4 on our list is a special trinomial. Is the first term a positive perfect square? Yeah. Is the third term positive perfect square? No. So it's a regular trinomial. Number 5 on our steps. Okay. What's my a value? 1, right? So all I have to do is look at my c value and think of factors of negative 28 that add up to negative 3. Well, negative 7 times positive 4 is a negative 28. When I add those, I get positive or negative 3, right? That's what I wanted. Okay? So I don't have to do the extra and make it a grouping problem because a is 1. So all I need is a minus 7 and a plus 4. The only thing different, we're used to seeing a y squared there instead of y to the 4th. That's all. All right? So just cut the y to the 4th in half. So they become y to the 2nd, right? Y squared. Hey, here's 2 perfect squares. Can I go further? What's between them? Addition. Could I go further since there's addition there? No. If it was subtraction, yeah, I could have gone further. All right? Here's a perfect square, there's subtraction, but is 7 a perfect square? No. So we're done. Okay? Anything else you want to go over? Okay. Today, I'm going to go back, look at this factor theorem, and go back to some synthetic division. Okay? All right, so it says all this stuff, okay? But all you got to really understand is this. What's 8 divided by 4? 2, right? Because 2 times 4 is 8, right? The remainder is what? If I did this long division, I subtract it. What's my remainder? 0, right? So if I divide 2 factors and the remainder is 0, or for 2 numbers, and the remainder is 0, that means the 2 numbers I get, the one I divided by and the answer, the quotient, are factors of the number we started with, right? You guys understand that, don't you? Okay. So what this is saying is if I have a factor like x minus 2, and I use synthetic division and get a remainder of 0, that means that x minus 2 is a factor of the polynomial. Okay? That's all that's saying. All right? So if you do synthetic division, we do whatever numbers here, and then we get 0 here, that last number, that means x minus whatever this was. If this is a 3, that means x minus 3 is a factor. If this was a negative 2, that means x minus negative 2 or x plus 2 is a factor. That's what that's saying. Okay? So here's the type of problems you're going to ask you. Determine whether x minus 2 is a factor of x squared plus 2x minus 4. Okay? So remember, what goes in our little corner? The opposite, right? Isn't that what we did when we had synthetic division? Emma? You staying focused? Okay. So I put a 2 in my little corner. I got an x squared, an x, and a constant. Do I need to add any zeros? No. Some of you forgot on the quiz last Thursday to add a 0 on whichever form you had. 1 for the x squared, 2 for the x, negative 4 for the constant. Drop down our 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 4 plus 8 is 4. That's my remainder. Is x minus 2 a factor of that? Yes or no? No. What's it got to be a factor? It has to be a 0. So we would say no. Okay? So if you're determining if a binomial is a factor of a polynomial, use your synthetic division. If you get a remainder of 0, you say yes, it's a factor. If you don't, like this example, you say no, it's not a factor. Okay? So do your synthetic division and then say yes or no. Go ahead and do this one, please. Tomorrow I won't be here. I have a wrestling tournament I have to go to. So we're not going to learn anything new tomorrow. We're just going to get more practice factoring and these types of problems tomorrow in class. It'll be an in-class assignment that you'll do in class and turn it in to the sub at the end of the period. You won't have any homework over the weekend, okay? Quit making up. All right. Is it a yes or a no?
Yeah,
It's a yes. You guys agree?
I agree.
All right. So what goes in my corner?
-5.
-5, right? We all okay with that part? Because when we set x plus 5 equal to 0, we get -5, right? So I got a 3 for the x to the 4th, 15 for the x cubed, -1 for the x squared, nothing there for the x. So what do I have to do? Put the 0 in. Did you remember that? Hopefully you did. So -5 times 3 is -15, so I get 0. -5 times 0 is 0, so I get -1. Remember, we're adding the numbers in, right, to get the one underneath. -5 times -1 is a +5. And -5 times 5 is -25. I do get 0 for my remainder, therefore, yes, x plus 5 is a factor. Okay? So since it's a factor, all right, I could write this as x plus 5 times what to equal that polynomial. Since it's a factor, that means something times x plus 5 equals our original problem. So what's this? Cubed, right? It's one less. So it's 3x cubed. If you want to put plus 0x squared, you can, but since it's 0, you don't have to. Minus 1x plus 5. Does that make sense? You know, we just said 8 divided by 4 was 2, because we got a remainder of 0, right? That means 2 times 4 is 8. So since this divided by -5 is this, that means x plus 5 times 3x cubed minus x plus 5 equals what we started with. Does that make sense to you? Okay. All right. Show that x plus 3 is a factor of that, then factor it completely. So it's giving us a head start, all right? What am I putting in the corner? -3. I got a 1 for the x to the 4th, 3 for the x cubed. What should be next? 0 for the x squared, -1 for the x, and -3. Again, we had to add a 0 here for that variable that was missing. Got to go right in order. Drop your 1 down. -3 times 1 is -3. Add, I get 0. -3 times 0 is 0. Add, I get 0. -3 times 0 is 0 again. -1. -3 times -1 is a +3. We got 0. So we did show that it is a factor, right? So when it says show, you're expecting to get what? 0. They're telling you it is a factor. Showing it is doing your synthetic and seeing you get a 0 there. Okay? So, I got my x plus 3. All right, so what's this answer here? 1x cubed plus 0x squared plus 0x minus 1, right? What is that x cubed minus 1 called? They're both perfect cubes, aren't they? So to factor it completely, I'm going to have to factor it like we did last night, the difference of cubes. So x plus 3 stays. Then I make my binomial and my trinomial. What's the cube root of x cubed? That sign. What's the cube root of 1? Take this first term, this x, and square it. Since that's minus, the middle's a plus. They're always opposite. What's x times 1? 1x. The third term is always addition or plus. And what's 1 squared? 1. Now we've factored it completely because we had that difference of cubes. Okay? So they're going to have a couple problems like that where it says show that it's a factor. So you show that the remainder is 0. Write your first factor times what you got, and then factor the rest of that 1 that you got. Finish it up. Does that make sense, that example? All right, so same type of problem. So what do I put in my corner? Positive 6. I've got 1 for x cubed, negative 5 for x squared, negative 6 for x. What's missing? The constant, right? So we got to put a 0 on the end of this one. We got to have all of them. 1 times 6 is 6. 1 times 6 is 6. 6 times 0 is 0. So I got a 0 on the end, right? So I've got x to the third. So this is x to the second. This one, right? So I've got an x minus 6. And then an x to the second plus x. Right, that's all I got. Can I factor that x to the second plus x? What's the first thing we always look for? A GCF. Does it have a GCF? Yeah. All right. So we got our x minus 6. And then we can pull out an x. And then what do we have left? X plus, what's x divided by x? 1. Normally, if we have a GCF, we put it all the way out front. If you want to do that, that's fine. That's probably what I would do to clean it up. But, you know, those are our 3 factors. X minus 6, x plus 1, and the x. Okay, so remember, always look for a GCF when you factor. All right, so those are the types of problems for tonight's homework. We'll probably have a couple, you'll probably factor a couple, and you'll figure out if a binomial is a factor. Number, if it's 0, yes. If it's not 0, your remainder, no. And they'll do these show ones, so you have to get 0, and then try to finish factoring. Okay? Oh, here's another, I guess. If it's got 4 terms, and you can do however you want here, but it's got 4 terms, what should I do? Group it, right? So let's go ahead and group it quick. I thought I was done with my example. All right, what's the GCF for the first group? Z squared, right? So we get Z minus 7. Since that's a negative in front of the 9, pull the negative out. What else goes into 9Z and 63? What's the GCF for 9Z and 63? 9, isn't it? So negative 9Z divided by negative 9 is positive Z. 63 divided by negative 9 is negative 7. So I got a Z minus 7 and a Z squared minus 9. Is that finished, Caitlin? No. What is that? Right, very good. You're so smart. Just like the rest of you, right? Z in the front, what's in the back? 3's. Square root of 9, right? 1's plus, 1's minus. Okay? So you have some there. Is there a GCF? No. Is it a difference of squares? Are they both perfect squares and a minus between them? Yes. What's the square root of 16 and to the 4th? 4n squared. What's the square root of 1? 1. Then what? Plus and minus. What's this? One on the right. another one. The one on the left we can't do because it's addition. The one on the right, what's the square root of 4n squared? 2n. What's the square root of 1? Plus and minus. Okay? So, make sure we factor completely. Now I'm done, I think. There we go. 36 to 54 even. All right, again, tomorrow you'll have an in-class assignment to work on. Nothing new, just giving us more practice. The more we practice these, the better we'll get at them.